Hello, this is Darren Pulsifer, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about the history of applications and how that's affecting data-centric architectures. Let's dive right in and take a look and see what is really causing most of this change to happen. And we can blame this all on IoT, Internet of Things, right? There's big promises on Internet of Things, how it was going to change the world. We need 5G to make this all happen. And it just kind of fizzled a little bit. Maybe because 5G was later than what we thought, but I still think that's not necessarily true. I think we have the infrastructure that's ready to go, but we haven't put into place a way to manage all the data that's being generated by all these smart devices that are out there. And that's a problem because I've got lots and lots of data. We're talking exabytes of data that is now being collected, and I can't stream all the data to my data centers. I need to do something with that. So we're talking about edge analytics, running AI on the edge. Well, how do I manage those AI on the edge? How do I do all this? We haven't come up with a great architecture or strategy for that yet. So we're going to talk today about what we have to change in our IT organizations or in our organizations in general to handle this onslaught of data coming from these Internet of Things. So let's take a look at some key elements of change that we need to work on. Now, this is pretty vanilla standard things that you'd have to do with any change that you're introducing into your organization. The first one is people. There are going to be organizational changes when you start introducing new capabilities that you need. So we have to look at the organizational changes. We also have operational changes, or processes now need to change. Things are now scattered a lot further away. Processes are going to change around security, compliance, governance. Those are some important processes to hammer out before just deploying. And of course, you're going to have some architectural or technological changes that need to occur as well. So today, we're not going to focus on all three. We're just going to focus on my favorite, which is the technology changes, because I'm a technologist. So of course, that's where I want to go first. So in order to understand how this is all working, let's take a look at how we deploy applications for missions today, or how we used to maybe 30 years ago, because it really hasn't changed much in the last 30 years. I create a reference architecture that has an application stack built on specific hardware, both compute, storage, and then I want to connect it to other things, so I put a network in there. This is how we've built things for a long time. Now, there's some issues with this. I don't get to reuse technology. Technology moves fast, so I may get some old equipment, but I've purpose-built and optimized for that equipment, so I'm going to stick with it. And really, you get technology drifts now, where you can't keep up with the technology as it's changing. Every 2 to 4 years, we're seeing a double in speed, in performance. I've already optimized for this. We're seeing new technologies coming out that are changing the way we think about things. So, lack of reuse, increased cost. This model worked for a long time, doesn't work so great anymore. So let's keep looking at some changes. The first change that happened historically over the last 20 years, it happened about 25 years ago, was virtualization. Now, people love this because now I could run multiple applications on the same machine without them really affecting each other too much, right? Because I have isolation of the VMs. Now, there are some problems with this, which we'll talk about around noisy neighbor, but hardware virtualization has really made it easy to deploy new applications and to run them all on the same machine. So instead of buying 5 smaller machines, I can now buy a bigger machine and run these virtual machines on there. It's not just compute, but I'm also running virtual storage and network functions as well. So this made it really easy that I can reuse hardware. I don't have my application tied directly to hardware, so I'm not optimizing to the nth degree to get every CPU cycle out anymore. Now the hardware is fast enough to do what I need to do in most cases, and we can easily now run an application on some more generalized hardware, which is exactly where we want to go. Okay, so this decreases costs, increases hardware reuse, but now all of a sudden security becomes a little bit more of an issue because I have two applications running on the same hardware, and I also have an issue with something called noisy neighbor, where I can have one application actually affecting the performance of another application, whether it is chewing up all the I/O bandwidth, or maybe it's network or storage, whatever it might be. So what's happened, probably it started in the early 2000s. We had another thing take off, and that was cloud technology. Now, some people say, wait, Darren, cloud technology and virtualization are the same. Well, a little bit of the same. Now we're actually sharing across multiple organizations, either in a private cloud or in a public cloud. But the main thing that we got with cloud technologies was the abstraction of operations. So I first had abstraction of hardware with the virtualization layer. Now I have abstraction of operations. They made it easier to now manage multiple machines, and they created an easy button basically for sysadmins, right? And they created self-service portals, all this stuff. All this cloud stuff came out in a technology or an architectural idea called software-defined infrastructure. And all the public clouds use it. All the private clouds now use that same terminology. And it now makes it easier now for me to spin up and spin down VMs, vSANs, virtual storage, as well as virtual networks. Now, it decreased my CapEx cost because I don't have to buy as much hardware, or maybe even hardware at all because I'm going in the public cloud. And it also decreased my total OpEx costs because I can have one sysadmin manage a lot more machines than they used to before. It also gives me the ability to burst into the cloud if I don't have enough capability, like at Christmas time for retailers, or at census time for like the U.S. Census. So those are some great things. Now, some concerns with this. Security concerns have increased even more because now I have multi-tenants running on the same machines. So I have to be worried about that. So I need to put extra measures in for security. Noisy neighbor becomes even more prevalent as I've got people from other organizations using the same machines I'm using, or the same network, or maybe even the same storage arrays that I'm using. And if I have a public and a private cloud, which we're seeing a lot more of, I now have some integration costs between the different clouds. So there's some things to worry about, but the pluses outweigh the minuses in here in most cases, right? You have to take that one step at a time. Now, over the last 5 to 6 years, we've seen an old technology become new again. And this is the container technology. So containerization actually existed before virtualization did. But it was hard and clunky to use back in those days. And a company, Docker, they came up with an easy button basically for containers. So Docker created the easier way to use containers. And it took off like wildfire, specifically around your application developers. Because application developers, they really don't want to mess with the operating system much. They just want to know that it's consistent across multiple environments, across their dev, test, and production environments. Well, VMs went one step there. Containers now focused on the same thing from the application stack down instead of the hardware up. So the service management layer that we're seeing with containerization of applications and the emergence of microservices have given me that ability now to be more application-centric, and I can map those applications to generic virtualized hardware that's been abstracted away. So we're seeing this large emergence here. It's really cool, and we've seen a consolidation in this marketplace, and the main winner on this is Kubernetes as far as the service management layer goes, which is great news because we have almost like a de facto standard out there on how this all works together. The good news here is now I have automatic deployment across multiple clouds. I've optimized my OpEx, and my CapEx was already optimized through the virtualization layer. But now I'm talking at the application stack and the service stack layer. So now I have automated fault tolerance, much easier to integrate with like overlay networks where I can integrate across multiple clouds and create a virtual network on top of two clouds and create firewalls and do microsegmentation all via software. It's a very cool technology, way to go. Another concern that I have though that pops up, security, number one concern. Containers are easy to deploy across multiple environments. Sometimes some people forget about security, so I need to make sure that I'm focusing on security, that it's baked into the way that I deploy. Also, you have an increase in complexity. The increase in complexity comes that I now have moved away from your normal 3-tier architectures to a multi-tier or maybe even a microservice architecture where I've got dozens of services working together to deliver an application solution. And then one of the other problems I have is where's the data? I can deploy a container anywhere, but it needs to be where there is some data. And in the service management layer, they really kind of punted on storage. They just call it volume. It's just a generic container concept, but it really doesn't manage the data itself. So there's still some issues there. Now, if you put on top of this ecosystem here, which is a great ecosystem, and you add Internet of Things, you now have an increased number of volume of data that's now spread across, not just in your data center or in the public cloud, but it's now spread across hundreds or thousands of smart devices that are out there. And it's not a little bit of data on those smart devices, it's large amounts of data. So I can't just ignore it. I've got to do something with it, right? It also increases visibility into what's going on, which is great, but security concerns now increased again. I have edge devices out there that the public can actually access. It could be a smart lamp, city light. It could be a smart traffic signal. It could be a drone that's flying around or security cameras. All that someone possibly could tamper with. So you've got additional security concerns. Your complexity just went through the roof because now I've got lots of different types of devices out there that I need to manage. And the other thing that's increased is your data locality, and where the complexity of where your data is enormous. So we've got to work through this. Now, one thing that we've seen also is that organizations are changing to handle this. Now, all this is colliding all together, and you'll see in the next slide why this is so important. But you've got now organizations that have a chief data officer. You've heard the new terms like data steward, data scientist, data engineer. They all have new use cases that they're bringing into the situation. And in our architecture, we don't have a place for those use cases to be managed. So we've created a new layer that we call the distributed information management layer, where these use cases can be handled. So let's see where this fits into our architecture that we already have. The application service, SDI, cloud layer, and the IoT devices here. This distributed information management layer is now managing data and information across all of these entities, IoT, public, private clouds, and it's matching those where that data resides with your application stacks and your service stacks. So I can dynamically allocate services and applications close to the data, or I can move the data close to the applications, or a combination of two. We're finding that we've already identified 3 different modes of operation on data and applications, and we're starting to uncover even more. So it's really exciting, actually. So this distributed information management layer is a key aspect to us moving forward. Now, another thing that we've kind of hinted on several times is security. Security is extremely important. So we need to make sure that we have security as an aspect where it runs from the common layers of hardware up through the cloud layers into the service stack layers and the application layers, as well as in the data management layer. And when I first put security in there, I added identity as one little box inside security. And after talking to several customers, they expressed the concern that identity needs to be at the top of the architecture because it's such an important aspect. So we move that to the top of the architecture. And when we talk about identity, now we talk about identity, access, authorization, and authentication of individuals, of applications and services, of IoT devices, and even of data. And I need to manage key management of that, which includes encryption, attestation, and so I can have trusted data and trusted devices out there. So we call all of this architecture together, we call this the edge mirror architecture. And you can see that many of the parts already exist, and it's just how they're integrated together. The one area that is probably the newest area here is that distributed information management layer, which we're starting to see some startups in this area and some more well-established companies already starting to build out those use cases and those architectural elements in that layer. Now, some people say, well, how does Intel fit into this? Well, one of the key elements that you need here is that common physical layer. Well, the common physical layer means that I can control and manage all of those resources, whether they're an IoT device or in the data center or on maybe it's a remote location or a remote office. I want to make sure that I can move the data if I need to, I can store the data effectively, and I can process everything, whether it's our Xeon processors at the high end or whether it's doing inference or doing AI on the edge at very low wattage. I have a full stack of physical hardware that's available. If you want to learn more about this, go ahead and send me an email, or you can contact me on LinkedIn or on Twitter. And remember, when you're going out there and you're looking at all this change, take a look at developing your data strategy, which should include people, process, technology. Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.